Hello everyone, welcome to Module 5 of the Database Management Systems class. In this session, we will discuss database design. Upon successful completion of this module, you will be able to explain the process and goals of database design, define user views and explain their function in relational database design, define database design language and use it to determine database designs. Create an entity relationship diagram to visually represent a database design. Explain the physical level design process. Discuss top-down and bottom-up approaches to database design, including the advantages and disadvantages of both methods. Discuss special issues related to implementing one-to-one relationships and many-to-many relationships involving more than two entities. In Module 4, we learned how to identify and correct poor table designs. In this module, we will study the process of determining the tables and columns or attributes of the tables that make up the database. Most database designers use a two-step process for database design. The first step is the information level design or the conceptual design. This step is completed independently of any particular database management system that an organization will use. The database designer designs a database that meets the organization's requirements as cleanly as possible. The second step is the physical level design. In this step, the informational level design is adapted for the specific database management system that will be used. Designers must consider the characteristics of the particular database management system. What are user views? A comprehensive database design is not a one-step process. During the database design process, organizations usually divide the overall process into smaller tasks by identifying individual pieces of the design problem. These individual pieces are known as user views. A user view is the set of requirements necessary to support the operations of a particular database user. The user view is a logical way of looking at the database setup to support the activities of a user or a group of users. A user view could be a set of reports, a requirement list, a personal discussion with database users, or a previous manual system. For example, at the BITS Corporation, a requirement is that the database must be capable of storing each task ID, description, category, and price. A cumulative design supports all user views encountered during the design process. Working on individual user views is usually more manageable than attempting to turn the design of the entire database into one large task. What is the information level design method? Earlier on, we stated that most database designers use a two-step process for database design. The information level design, also known as the conceptual design, and the physical design. The information level design involves representing individual user views. For each user view, the information level design requires you to do the following. 1. Represent the user view as a collection of tables. 2. Normalize these tables. 3. Identify all keys in these tables. And 4. Merge the results of steps 1 through 3 into the cumulative design. Sometimes, based on the information or requirements received from users, the correct design of a collection of tables may be obvious. However, when the correct design for a collection of tables is not so obvious, implement the following 4 steps. 1. Determine the entities involved and create a separate table for each type of entity. In this sub-step, you mainly name the tables. 1b. Establish the primary key for each table. Recall that the primary key is a field. So in step 1b, you are simply adding a field or fields to the table or tables. Step 1c. Determine the properties or additional fields for each entity. Step 1d. Determine the relationships between the entities. There are 3 types of relationships in relational databases. These are one-to-many, many-to-many, and one-to-one. To establish a one-to-many relationship, include the primary key of the one table as a foreign key in the many table. To establish a many-to-many relationship, create a new table whose primary key is the combination of the primary keys of the original tables. For a one-to-one relationship, the simplest implementation is to treat it as a one-to-many relationship. After creating relationships between the tables, the next step in the informational level design is to normalize each table. In normalization, the goal is to go from first normal form to third normal form. A careful planning in early phases of the process usually rules out the need to consider the fourth normal form. In step 3, you are required to identify all keys for each table. You must identify the primary key, which can be a natural key or an artificial key or a surrogate key. You will also need to identify the alternate keys, the secondary keys, and the foreign keys. It is through the foreign key that you create relationships between tables and enforce certain types of integrity constraints. Types of primary keys. There are 3 types of primary keys that can be used during a database design. A natural key, also known as a logical key or an intelligent key, consists of a colon that uniquely identifies an entity. An artificial key is a colon created for an entity to serve solely as the primary key and that is visible to users. A surrogate key, also known as a synthetic key, is system generated and is usually hidden from users. The database design language is a standardized way of describing entities of a relational database. When using the database design language, you write the table name followed by the columns that make up the table in parentheses. The columns that make up the primary key are underlined. The abbreviation AK identifies alternate keys. The abbreviation SK identifies secondary keys. The abbreviation FK identifies foreign keys. Foreign keys are followed by an arrow pointing to the table identified by the foreign key. What is an entity relationship diagram? The entity relationship diagram usually represents the database structure. We learned in Module 1 that in an arrow diagram, the rectangle represents each entity. Entities' names appear above the rectangle. The primary key for each entity appears above the line in the entity's rectangle. Other columns of the entity appear below the line in the rectangle. The letters AK, SK, and FK appear in parentheses following the alternate key, secondary key, and foreign key. For each foreign key, there is a dotted line leading from the rectangle for the table being identified to the rectangle for the table containing the foreign key. In step 4 of the informational level design, you merge the results of steps 1 through 3 into the cumulative design. You will have to combine all the tables that have the same primary key to form a new table. The primary key of the new table is the same as the primary key in the tables combined. The new table contains all the columns from the tables combined. If there are duplicate columns, remove all but one copy of the column. Make sure the new design is in third normal form. What is the physical level design? The physical level design is undertaken after the completion of the information level design. The physical level design involves the implementation of the design for the specific database management system selected by the organization. Most database management systems support primary, candidate, secondary, and foreign keys. To enforce restrictions, programmers must include logic in their programs. Top-down versus bottom-up design. Another method used to design a database is the bottom-up design method. In this method, specific user requirements are synthesized into a design. The top-down design method is the opposite of the bottom-up design method. The top-down design method begins with a general database design that models the overall enterprise and repeatedly refines the model until the design supports all applications. Note that the ideal strategy is to combine the best of both approaches. When designing a database, it may be helpful to use a survey form to collect required information from users. The completed survey form must contain all the information necessary for the design process. This information includes entity information, attribute information, relationships, functional dependence, and processing information. You also need to obtain estimates on processing volumes. Obtaining information from existing documents. In addition to conducting a survey to collect information, you can also use existing documents. Existing documents can furnish important information about database design. The first step in collecting information from an existing document is to identify and list all columns and give them appropriate names. Next, identify functional dependencies and then determine the tables and assign columns. The entity relationship model. The entity relationship model is an approach to representing data in a database. In the entity relationship model, diagrams are used to represent high-level, abstract, and conceptual representation of data. Entities are drawn as rectangles and relationships are drawn as diamonds with lines connecting the entities involved in relationships. When an entity serves as a relationship between other entities, it is known as a composite entity. When the existence of one entity depends on the existence of another related entity, an existence dependency exists. An entity that depends on another entity for its own existence is called a weak entity. Cardinality is the number of items that must be included in a relationship. Cardinality can be maximum or minimum. Maximum cardinality is the maximum number of entities that can participate in a relationship. Minimum cardinality is the minimum number of entities that must participate in a relationship. For this week, you're required to read chapter 6 of the textbook, that is pages 189 to 227. Complete quiz 5. Complete assignment 5. Submit your final project proposal. Take part in discussion 5. Please take note of the due dates and plan accordingly.